This problem solves an absolute value equation and looks at how to look at it graphically. So an inequality with absolute value. Alright, f of x equals the absolute value of -4. Now, let's look at what this graph produces, okay? If you were to graph it, put in like 1, out pops a 3. So 1, 3 is a point on this graph. If we put in another value, let's put in, I don't know, say 0. That's an easy value, right? F of 0 is 0 minus 4. Absolute value of -4 is 4. So 0, 4 is a point on the graph as well as 1, 3. And you could keep doing that, right? And then you would actually get a graph of this function. And what it will look like is some sort of V. Okay? Now the important part to remember is that the input is the x value. Input, the output is the y value, right? F of x is actually y. So you get 3 for y and 4 for y in this case. So we're looking at values that go into the function x, 1 and 0, and what do they produce out? So that's the key I want you to remember because that's how the graph is created. Now look at what I've changed here, the f of x to y. Now it looks like you get x in and y out. So we will now graph this function and put all the values in here and see what we get out and plot it. Alright, I've plotted the graph. I've plotted the ones that we had, 4, 0. What was the other one? 3, 1, I think. Yeah, I think that's what it was. Oh, I was mistaken. It was 1, 3. So 3, 1, 3, and 4, 0. Okay? So there they are. Here's the rest of them. Creates that V. Now this is the absolute value of x minus 4. Now I want to look at the inequality. So when is it greater than or less than or greater than or equal to? Because this is the equal to. All of these values make this true, this statement true. -3 is equal to 7 when you put it in there. 1 is equal to 3. 4 is equal to 0 when you put it in there. And that's creating this graph. Okay? Now let's look below here. This is the equation I want to solve. When is the absolute value greater than or equal to 5? So this is the equation you must solve. What values do you put in for x so that it's greater than or equal to 5? Well, let's move back up to my graph. Now look at this. We graphed the function f of x equals absolute value of x minus 4. We graphed this function right here, right? So before it looked like this. F of x equals absolute value of x minus 4. We graphed that graph right here. Well, now this is the y, right? Y equals. So if this is y, this whole thing is y. Okay, that whole thing is y. Y equals this, so this is y. The whole thing as a whole, one stamp. So what does this say? If this is y, couldn't I just rewrite it like this? Y is greater than or equal to 5. So when are the y values greater than or equal to 5? Well, look at my graph. Here's y value 1, y value 2, 3, 4. Oops, there's 5 right there. When are they greater than 5? Here. Now the graph is greater than 5. I'll change my color. Right here. Greater than or equal to 5. All these y values on that graph, all those points, 6, 7. But look over here. Here's 5, 6, 7, 8. They keep going up, right? Those y values are greater than or equal to 5. Now the question is what x values do you put in there? What x values do you put in there? Well, look at the corresponding x values. -1, -2, -3, right? Here's -1, here's -2, -3, -4. They have corresponding y values that are greater than that 5. Over here, 9, 10, 11, 12, etc. Going to the right, they have y values that are corresponding to greater than 5. Let's look at another graph now with that in there. I'm going to graph this one right here that I have, but then I'm going to go ahead and graph this one also, just so you can see it on the graph as well. So now I'm on a calculator, and I'm going to go in there and graph another one here. The 5, y equals 5. There we go, it's in there. Alright, there's the graph with the y equals 5. So now look at what I've done is I have the regular graph here of f of x equals absolute value of x minus 4, and then I put in y equals 5, and that's because the absolute value inequality said greater than or equal to 5. So now you can visually see what y values are greater than or equal to 5. All these, like I said, and all of these over here. Our job is to solve this though to when the equals 5, because we got to find that magic point. We got to find the magic point of where the equal 5 is and where the equal 5 is. So I'll move this down just a little bit. What I usually do is I just rewrite it. Absolute value of x minus 4 equal to 5, and I split it up into the two cases. X minus 4 equals 5, x minus 4 equals a negative 5. And then I add a 4 to both sides. Here I have x equals 9 and x equals what? Negative 1. So these are the two spots that if you put 9 into this equation, you will get exactly 5, right? If you put negative 1 into this equation, you will get exactly 5. 5 equals 5. So negative 1, 5, and 9, 5. And they are on my board here. Negative 1, 5, and 9, 5. Right there. Squeeze it in there. Okay, now I have those two equal to, I have those 2 points where it's equal to. Alright, back to this graph. Here I have that y equals 5 line in there. I have the red line for the absolute value. Now again, look at equal to 5 right there on that dot, equal to 5. That's why I draw that horizontal line in, because that's the line y equals 5. Right there, they're equal to. Now look above the line, the y values are greater. Look below the line, the y values are less than. So the equal to is exactly on the line, the greater than is above, the less than is below. So now you just need to pick out the x values that are the solution, that is the solution to the inequality that you started with. We started with the absolute value of x minus 4 is greater than or equal to 5. So these y values are greater than or equal to 5. And look at the x values are just given to us. We solved and found the equal to. So now we can say 9, 10, 11 will produce numbers to the right, right? These guys will produce numbers of y values that are greater than 5. Also, negative 1, negative 2, negative 3, negative 4, negative 5 to the left. These guys up here, because that's the part of this red line from here to here, right? So this is the part of the graph I'm talking about, this green part now. These points on the green line all have a y value greater than or equal to 5, right? Equal to, greater than. Okay? And so now we just want to show the x's that produce that. So all we got to do is write interval notation from negative infinity up to negative 1, produce all those. Union with from 9 to infinity, produce all those. So if I go, okay, so here's my horizontal line again. I just switched back here so I could draw, right? We were interested above, because this is the equation we need to solve, the absolute value of x minus 4. Oops, that's a 4. There we go. Absolute value of x minus 4 is greater than or equal to 5. That's what we were asked to solve. So what we needed to do is to find the two equal to's. That's the work. It was x equals negative 1 and x equals 9. Those are equal to 5 when you put them in there. Okay. And then we just had to, what I would do would just draw a V. This is the work I would show. Put the 5 here. And then again the x's that they're equal to, the 9 is on the right side, the negative 1 is on the left side, right? That's those 2 points. These are left and right now. What inputs equal 5 as an output. And then go look. I want the y values of this whole thing to be greater than or equal to 5. Here they are. Oops, here they are, right? Let me get the right color if I can. Right here. This and this are the y values. So you just got to represent the x values that produce those y values. Here and here. Negative infinity to negative 1, including the 1. 9 to infinity, including the 9. Reason why I'm including the 9 is those are the two values that equal 5 when you put them in there. And this would be the work. You know, right here, this is the work for it. You just got to solve this, you know, which I did below. If I scroll down, you'll see that work right here. That's where I did this equal to. Okay? But this is why it works that way. Why you can use and visualize a graph and then set it equal to this, or the equal guy to the 5, and then find greater than or equal to it. Now if I wanted to find less than or equal to it, or even just less than, I look at the graph. These are the x values that produce the less thans, right? Here's 5, here's less than 5. So if my equation's this, or equal to, I'll say, well, it's the same work. Do the equal to like this, now but look at the graph. Well, these x values in here, all the way in here, have y values that are actually less than 5. 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, right? They're less than or equal to. So what are the x values that produce those? We'll just look at it. -1 to 9. But it's in between. -1 to 9. There's the answer to this one. Same work, just looking at the picture. So you just got to look at, whoops, that's a bracket 2, equal to. Same work, you just got to look at the picture and pick out if it's greater than, it's above, and those are always the outside, right? Outside, look at outside because it's going to be outside of this point. And if it's less than, it's in the middle. So it's going to always be one of these type of things, just in between. It's an in between, it's inside. Okay? Hope that helps.